I'll call us to order here, like we're at court. I'm Tom Hyatt with Missouri Rural Water Association. Their training person on staff, one of the training people on staff. And actually today I have with me a co-worker, Jim Enterline, our energy audit assessment guru. I forget what the official title is. What is it, Jim?
Energy efficiency.
Energy efficiency, and he does a great job with energy and electronics and computers. Thank you, Jim. This is a brand new computer. It's getting its debut today with a class. First thing it's being used for is today's class. And Jim helped, well, for one thing, he got these computers for several staff members. It's the first, I will say, I've been on board Missouri Rural Water Association for almost 2003, so almost 15 years now. And this is the first new computer I've ever had. I've had hand-me-downs and hand-me-downs and hand-me-downs on computers. So anyway, this computer I think. So goodbye eBay, hello Walmart or whoever. Anyway, glad to be here. Of course, my hometown, city of Fredericktown. Appreciate Fredericktown offering us donuts and coffee. If you weren't aware those were back there, be aware. Feel free to even get up now if you want to get a cup of coffee or grab a donut and do so. The restrooms are past the refrigerator there. Men's on the left, the women's on the right. I'm going to remind us while I'm thinking of it, if you would please silence your noisemakers that you brought in today with you, and we'll ask we'll just tune into the class, put all our cares away, and check our messages, I guess, on breaks and stuff. Rosters, I do have a roster from Missouri Rural Water Association that's been revised, and the DNR roster, of course, the important ones that will give us renewal credit training, and I'll be passing those out. I typically wait till after lunch to do that, so we'll be doing that. I'll set those aside. Don't let me forget them. They're right in front of me. That means I probably won't see them. Won't see them. But one thing that Missouri Rural Water Association has done recently is change the look of our roster sign-up sheet. And why we've done that is because we've started to put a space for your mobile phone number and your email address. And they also want to know what carrier you have, Verizon or AT&T or whatever, so that we can get you more in our database so that we can send text messages, emails to you directly to let you know when we're having class. We have, for a little more than a year now, we've kind of gone away from sending out flyers or postcard reminders. Hey, we've got a class coming your way. And so we're figuring this is the day and age of these little walking computers that we all tend to carry with us. And so it's just a matter of kind of getting used to going online. We always recommend you go online, moruralwater.org, and there's a button right there on the homepage that says training. I don't even use that training button. I just scroll down the homepage, and you'll see, based on calendars, everything in May now, and then June, July, all our events. And events are typically training kinds of things for the most part. So you can see what topics there are and where they are, and you can click on the expansion. I think the little button says more, and open it up to get more details and register right online. So we're trying to make it really easy so that you can just do that from home or from the office or wherever you happen to have your internet set up on your computer or on your phone. Today is about drinking water regulations. Drinking water regulations. Now, I lived and breathed regulations when I worked here and managed the surface water treatment plant here in Fredericktown. This is where I hail from. So I was pretty familiar with regulations because, boy, we had to live with a lot of them. You have to live with a lot of them when you're in the water industry or the wastewater industry. But other people on staff tell me that topic's a pretty dry one. And not very fun, not very interesting, and pretty heavy to bear. So I'm trying to change up things a little bit so that I'm not just up here all day lecturing, but that we have a little bit more interaction. So I'm hoping we're small enough, intimate enough group that we can interact, talk about experiences, ask questions, and I've even built in some, I'm hoping, fun things to just break up the monotony a little bit and get us participating. First, though, I'd like to do our introductions. I, again, have been on board Missouri Water almost 15 years and came from the city of Fredericktown right here at the water treatment plant. And mostly I'm doing training, do technical assistance as well. Yeah, I do multi-day certification courses and then these one-day classes for renewal credit, and then I'll send it to your way, Danny.
Denny Durr, City of Piedmont. I'm the chief operator at the treatment plant. Been there about 10 years.
Okay.
Scott Lamb, Buckman, North America, and Cadet, Missouri, with private industry. So I've been there about 12 years or so.
And I knew I recognized your face, Scott.
Yeah. It's been a few years, but yeah.
It's been a while.
You were my multi-day certification instructor, so.
And so today you come back to throw rotten tomatoes, right, or whatever.
Al Kern, doing Hamburg, South End well, and Central well for 10 years.
Well, good seeing you again too. It's been a while, huh?
Kevin Brooks, City of Leadwood, worked water and wastewater. I've been there 4 years.
4 years. And tell me your first name again.
Kevin?
Kevin. Okay. Good.
Dean Wampler, former correctional center, maintenance supervisor, been there 15 years.
All right. And you're still working there, Dean.
Yeah,
Okay.
4.5 more years and I'm gonna join him.
Oh, good. That's light at the end of the tunnel. 4.5 years.
Stephen Delaney, he's retired, state of Missouri, 27.5 years.
And you say retired with some sense of pride, don't you?
Say it again?
You say retired with some sense of pride.
Yep.
You've earned it. 27 years you were there?
27.5, yep.
27 and a half. Wow. That's a good long stretch. Good job, Steve.
George Keeter Water Well Service, Gordonville. Been in business since '63.
Okay. From Gordonville then, huh? Okay. Good.
I'm Nelson Eager with Upper Bend Road Subdivision Well King. This will be the 15th year that we've been on this. This is my partner in crime.
Janet Penrose with Upper Bend Road Well Subdivision, and I don't know how long I've been there. I think a little bit longer. I think that's when it was in a mess.
That's right.
We're all good now.
Oh, that's good. So how is it you're from Cape and I'm from Fredericktown and I'm going to drive farther to get home tonight than you are because I'm going to Sykeston. Because I got a class tomorrow. Home is where I happen to stay tonight.
Yeah.
We're going down in the country.
You're going down in the country.
Got down in the country, yeah. Right? So, yeah.
That's kind of a joke. I was in St. Louis and I asked some friends of mine where their daughter was. Said she went to the country for the weekend. I said, where'd she go? She said Sykeston.
Oh, is that right? Sykeston, yeah.
And she just down there to find out her tax lights and run the water down there.
Well, if you're from the city of St. Louis, Sykeston is going to a little rural town, isn't it?
Yeah.
Anything south of Warren.
Yeah. But Sykeston has a couple dozen restaurants, I'm sure more than that.
Oh, yeah.
And that makes them a big city for me. You know?
Yeah.
And of course, you guys really are a big city. Cape Girardeau, I was just in Cape on Saturday, and fact, because my younger son is going to be attending SEMO
SEMO, yeah.
next fall, and I'm hoping he's still at SEMO this time next year too. Anyway, so we went there for their
Orientation.
Orientation,
Yeah,
thank you,
yeah.
yeah.
My daughter, she graduated from there.
oh, did she?
SEMO, 2010.
Did she like it?
Yeah,
Good. Well,
yeah.
That's a very well-respected school. Very well-respected.
I believe it is, so I'm hoping he'll do well, and he wanted to stay relatively close to home.
Right, right.
My older son, he went up to Maryville, Missouri, about a stone's throw from Nebraska. He got as far away as he could and still maintain residence. So here's what we're going to do. I want us to start off with just this is not to put anybody on the spot or worry about how you do or anything, but I'd like us to divide into, I'm going to say teams of 3 because there are 9 of you. You 3 already have a team.
Yeah.
And Denny, if for this exercise, you resume your seat back there, but if you might move down here and join these 2 gentlemen, and maybe you 3 be a team if you would. So what we're going to do is we're going to start with a game. Yes, sir.
Because we're videoing this for training, does anyone not want to be on camera? If you don't want to be on camera, I'll make sure that we don't point it towards you. Okay, thank you.
Okay. And on YouTube and on all the other things we
Yeah,
have
you know what's
posted
wrong
too.
with
I hate it. I mean, he's not.
Yeah, go ahead.
YouTube, I want some rights to it.
Yeah, there you go. I'm going to pass around these little slips of paper that I measured perfectly and precisely and cut all perfectly the same size as you see. And I'm going to ask you to take one of each color. There are 8 different colors, and I'm going to show you in a minute here what those colors represent. Let me go to the next thing. So you got each, take 8 slips, different colors, and what I'm going to ask, I'm going to say a word or a couple of words, phrase, that we associate with a regulation. And I'm going to have the list of regulations up here. And all I want you to do in your group is, and you can talk amongst yourselves real quick, but we're going to kind of keep it going quickly. We're not going to let it sit too long. But just throw up a color that is associated with the regulation you think that phrase goes with. Okay, so here's what we've got so far. Well, wait a minute, I got to get out of this and go to the board here. So here is the board. So we've got yellow is the revised total coliform rule. I've got the abbreviations here, but I've got it spelled out over here. So if we forget. Disinfection byproduct rule. Groundwater rule is green, so that's, this doesn't show such a great color difference here. This is supposed to be orange. On my screen, no, the disinfection byproducts is brown. I don't know why that's showing like orange there. That's supposed to be brown. So, do as the word says, not as the color necessarily shows. It looks orange or red to me. But on my screen, it's brown. The groundwater rule is a light green. This thing is really dark, so I put it over here too. Lead copper rule. Dark blue. Tan is what I was going for with this color for RADs or radionuclides. TMF is, there's where I have red. That's actually a red color on my screen. TMF, Technical, Managerial, Financial. Then green, it's a dark green instead of the light green for groundwater rule. The dark green is public notification. And then the orange is construction permit. So if you're not sure color-wise, because these colors didn't come out exactly right on the screen, the words are next to them for the color. So brown, again, that's the one that's the least similar to what it's supposed to look like. And that is disinfection byproducts is brown. So, okay, what I'm gonna do is I'm just gonna throw, and then I'll kind of track progress here on this. So the first phrase that I'm gonna give you is action level. Which regulation does action level suggest? Talk amongst yourselves if you wish, in your group, your team. I've got one placard, I'll placard up. And, anybody else? Feel free, don't worry about it being, if it's right or wrong, we'll just move on. The team with the most points, however, will be the lead team will be the one who leads us in a game of play after lunch sometime. And for that, I have one of the MRWA cups for each member of the team, so. Okay. Anybody else? Got a color? Okay. Color. And is that light green or dark green?
This is dark.
Okay.
Yeah.
The actual color should be the blue, the dark blue,
Okay.
lead copper rule for that one. That was, so don't worry about it. Looks like no team got it. Okay, the next phrase, which regulation does this associate with? 120-day limit.
Orange.
Okay. No, it's a light green. It is the groundwater rule. Okay, don't worry about it. We'll just keep on, we'll try to roll along here. And we'll cover these terms as we go through the day. Here's the next phrase, direct delivery.
Yellow,
What's it called?
yellow.
Okay, no, so I'm gonna call you team 1, 2, and 3, just kind of go
Okay.
around. So teams 1 and 2 that time
They got it.
did have, I think I need to make this one smaller so I can get everything in here. So I'm gonna put 1 and 2 in there. Okay, the next phrase, capacity. Capacity, what reg does that associate with? Okay.
You sure some of those don't have two answers?
That's your color? No, I think you're right, Jim. I think some of them do. Is that the one you're putting up? Okay, what was your color back there again? Orange, and you have red. Red is actually it's TMF. technical, managerial, financial capacity is what they do, what they said. So that was group one, so we're gonna do one there and kind of take you out of this one here. So, okay, so one is in the lead. Now we got the next phrase is toxic kidney effect. Okay, no, it's TAN, and that is radionuclides for that one. Next one is organic matter. Organic matter. Okay. Okay. Yellow? Is that the one? You had brown, and team one actually did have that. It is disinfection byproduct rule. Don't worry about it. Again, this is just throwing out phrases. You throw out things out of context for me, I'm going to be lost. So I'm not. It's not a. It's just meant to kind of get the topics on the table at first. The next word is authorization. Authorization. Okay. Okay. Is that your color? Okay, group three. Add it. Oh, did your change? Okay, so group two and group three had that, and it is construction permit. All right, let's see. Next one is 30-day treatment technique. 30-day treatment technique.
What was the phrase? I didn't.
30-day treatment technique. Okay. That one? No, that was, it's the revised total coliform. So, those are just some ways of trying to get some of these ideas out there. Don't be concerned about that, but what I see that group one, team one is in the lead. So at the end, or later in the day, we have a different little game to play. Team one will lead the game board. They'll start us off. Okay, so let me close this one out.
Don't feel bad, I didn't know the answers either, and I'm supposed to know.
Let's see. Since I'm just trying to close this thing. Don't save it, no. Okay, so we'll be back to this. So construction permits is the first topic for the day. And tell me, when are permits required? most of today, I'm going to kind of be asking lots of questions about these topics. Because I think a lot of times this is a review for renewal credit, but you're pretty familiar with some of the regulations, at least some of them, some of the details of each of the regulations. When does DNR say you have to have a construction permit?
I think the only time we changed the actual well configuration or any of the piping in the well, ground source.
Okay, that is true. Anything in the well that you change construction-wise, also we could extend that beyond that to the distribution system or a treatment plant. If we change anything, if I take out let's say in a water line, if I take out a 6-inch cast iron pipe and I replace it with a 6-inch PVC pipe, do I need a construction permit? Okay, no, you're right, you don't. Because all you're doing there is you're not changing a size, you're just changing the material, getting rid of maybe old pipe to put in something new, less corrosive. So you don't really need to then, right? So
You just need a permit to put it in, right?
you don't have to if you're replacing the same size
Well, what I'm saying
line.
is originally, if you were installing it originally,
Mhm.
you would need a permit.
Originally you would. But if I change all of a sudden the 6-inch and I say I want to go up to an 8-inch, that's different. Then I do need a construction permit, right? Because maybe I'm changing dynamics in my system, flows and pressures that my pumps can't keep up with, or are incompatible with my storage tanks, or are going to leave somebody on another part of my system without enough pressure. That's why they want an engineer to make sure that that's going to work at your system and that you're not going to cause problems there. So any construction, alteration, even an extension of lines, if all of a sudden the city of Fredericktown were to incorporate another subdivision just outside the city limits and bring them in to their water system, they'd have to get a permit from DNR. And then who is the one who actually has to submit that to DNR?
Owner of the system.
Okay, the owner of the system has to actually get somebody,
Engineer.
an engineer, right? Somebody with that engineer license to submit to DNR. And then how long is an approval good for?
Usually 6 months to begin.
Okay, they probably do have a time frame for beginning it. They say 2 years is really the construction's not begun within 2 years. You have to go through the authorization again. So if you get something approved and 2 years passes before you act on it, then you got to go through the approval again for it. Maybe something in that time's changed in that. So if a change affects water quality, the capacity of the system to deliver water to its customers, or any sanitary features or performance, that requires a construction permit. But identical replacement of components does not. When you have a supervised construction program, then that's been approved in your system. First of all, what is a supervised construction program? Anybody have that at your systems? Okay, so that is when you get approval for what's going to be a large kind of project that might require multiple phases to be done in different stages along the way. And DNR can give a permit for the entire project, massive project, for a 5-year period, so that anything that you start within that 5 years, that's part of that, has already been approved by DNR. They can review it periodically and they can revoke it, but basically they're looking at it and deciding whether to approve it from the beginning, and then they give you this 5-year period. So what here requires a construction permit, would you say? Replacing a 4-inch galvanized with a 4-inch PVC pipe? No, it doesn't, I heard somebody say. Looping a dead-end line? Okay, I see nodding head saying yes. What about changing injection location for chemical feed?
Yes.
Okay, I see a no, and I hear a yes. And I would have gone with the no in the past, thinking, that should be my jurisdiction as chief operator to do that. But no, they actually say if you're changing where you inject a chemical, if you're installing, it's a new installation, to install a new injection point in a treatment plant. So that too would require a construction permit. Replacing 4 35-gallon bladder tanks with 3 50-gallon bladder tanks at my well house. Yep, I see a head shake, yep. Installing pressure reducing valve?
Yes.
That does. Replacing a 1-inch well vent with a 1.5-inch well vent? It does. It does. Actually, this is the size that the design guide stipulates should be the minimum size. So if you had this size and you were upgrading, you would actually be trying to comply with what the design guide says you should have as a minimum. But even though you're doing that and it's considered a favorable improvement, kind of an improvement, it still would require construction permit. Any questions or any things you've experienced along the way about construction permits that you want to tell us about?
What was the one about the water tanks, 4 35-gallon and 3 50? What was that, yes or no?
That was a yes.
Yes.
When you do that, you're changing things. I know of a homeowner association down in southwest Missouri once that did this kind of thing. They just changed, they had, and I don't know what the sizes were, but they did have a little difference in the size. And so they thought, well, we've got instead of 4, we could use, or instead of 6 of the old ones, we could use 4 of the new ones because they're a little bigger. But DNR didn't like that. You can't do that without an approval. So, okay, so that was a quick, that was a quick, easy one. We got through it. All right, so let's see. Module 2, let's see if this will work. There it goes, it did it. So now we'll talk about disinfection byproducts. Anybody in here have issues with disinfection byproducts? I know the city of Fredericktown here, because it's surface water, struggles with that. You guys are groundwater under the influence, but you have wonderful water down there at Piedmont, right? You don't really have any issues with disinfection byproducts. And nobody else here does, I imagine, right? So, okay. So this isn't even going to be something that's going to affect most of you folks. Does anybody buy water from another system? You guys buy water from?
From our own system, when the state signed the wells over to the city,
City of Farmington runs them.
they run the wells, and we take care of everything now from outside the well house to the housing units.
They have to pay them,
Okay.
they have to pay them inside.
But you still get water from City of Farmington?
No. Well,
So
the city-
we get it from our wells, we don't get it from their system, we get it from our 4 wells that pump
Oh,
for us.
the city of Farmington is running their wells now to go to the operation.
they took over the operation. I see. Okay. Okay, so how are disinfection byproducts formed? I won't belabor this too long because nobody in here is affected by it. I'm going to take this class around the state, and there are quite a few systems, especially in the north, that do have issues with this. Precursors are things that are naturally occurring organic substances in water. So that's what this NOM stands for, natural organic matter. And then there's bromide too that can occur naturally. Natural organic matter combines with chlorine and chloramines to form chlorine, to form total trihalomethanes and haloacidic acids. And chloramines form iodoacids and NDMA, or nitrosamines. Those are two byproducts that are not regulated, or groups of byproducts that are not regulated right now. And then chlorine dioxide will form chlorite, and bromide mixes with ozone to form the other one, bromate, but very few use ozone in Missouri. Health effects, so for disinfectants, chlorine and chloramines typically are the ones we're using. At high levels, they say things like eye and nose irritation, stomach discomfort, anemia. Anemia is a shortage of healthy red blood cells in our system, which can make us feel tired and weak. And then for byproducts, when the chlorine mixes with organics, or the chloramine mixes with organics primarily, it can form cancer is the biggest concern, but other issues too, liver problems, kidneys, central nervous, anemia, and reproductive problems. So EPA set these maximum residual disinfectant levels. Those levels are intended to try to cap how high we go with our disinfectant in our systems to try to prevent health-related problems from the disinfectants themselves. Does anybody know off the top of your head what the maximum residual disinfectant level is for, let's say, chlorine?
2 parts?
Double that.
4?
4.0. And the same number is true for chloramines, 4.0 on a running annual average for both of those. Chlorine dioxide? Anybody know?
Have they changed that for 1.5? It used to be 1.5 at the end location.
In terms of the minimum you've got to have?
Yeah,
So this is the maximum.
the maximum.
Yep, now on the minimum side, they typically say, 0.2 parts per million minimum on anywhere in the system for chlorine. 0.2 parts per million. However, the regional office, southeast and southwest, tend to say 0.5. I think they like a little cushion so that you're not right there at bare minimum. 0.2 is pretty minimal. But yeah, that would be more of the minimum side. And then these are the maximum. So 4.0 on the maximum for chlorine and chloramine. And for chlorine dioxide, it's 0.8 milligrams per liter. So these are the maximums there. And then disinfectant byproducts, total trihalomethanes is 0.08 milligrams per liter. Haloacidic acids, 0.06 milligrams per liter. Bromate, 0.01. Very few systems have to deal with this, but there are a number of systems that use chlorine dioxide. So the byproduct of that is chlorite, and that's a 1.0 part per million or milligram per liter amount. Each system has to identify its sample locations and schedules and have representative sample sites in their distribution system, just like they have to with the total coliform rule. The trihalomethane haloacidic acid levels are based on a running annual average as well, and based on a locational running annual average now with stage 2. So in the past it used to be if I take 4 samples in my system, and this is one of the locations, let's say, I would take this location and add the results with the other 3 locations, and then divide by 4 and get the average. Now, this location stands all by itself for compliance purposes. Next quarter, this location added to this quarter's number, and then take the average to continually determine whether you're in compliance or not. And then there's this long schedule. Most systems, what's this? Anybody have an idea what this subpart H stands for in EPA regulation? I don't think you see it in the state regulation. That, I know it because I came from one. That's surface water. I don't know how they got this subpart H to represent that. Surface water, groundwater under the influence, surface water are called subpart H systems in the EPA federal water regulations. And so systems, here's the town, Town's about 4,000 population. And so for every quarter with the stage 2, we used to take 4 samples. Now they're reduced down to 2. What they've done is they've made those 2 locations more like hot spots, like worst case scenarios spots. We've got fewer samples to take, not 4 but 2 now, but now the 2 are more likely suspects for having higher levels of total trimethyl salicylic acids. And then for groundwater systems, most of you are from groundwater systems, right? So population served, what's your population?
To give you the population, we have 22 users.
22 users, okay. So you are this real small, less than 500. So once a year, you're collecting 2 samples for total trihalomethanes salicylic acids. It might happen so infrequently that you forget you do it. But there's a kit that comes in a cooler once a year that you do. And then your population is, how many folks do you serve there at the prison?
We got 3,000 inmates, about 800 staff.
Okay, so pretty good sized population. So you're between, and you're all groundwater sources there. 599, 500 to 9,999, excuse me. So you too would be taking 2 once a year from there. And you're a subpart H system, aren't you? And what's the population of Piedmont?
We're between the 500 and 3,500.
Oh,
We're
okay.
about 2,000.
Okay, so you would be every quarter taking a couple of samples, just like City of Fredericktown would. And you guys are a real small community, aren't you?
24.
24, okay, and groundwater, so you're down here too, folks, okay, so. Challenges for consecutive system. What's a consecutive system? What's that stand for? Consecutive systems are the ones that,
Water from another.
that's it, they buy their water from another system, or they buy some of their water on a regular basis, at least, from another system. So they have some challenges because they get water that potentially has high levels of organics in it, or maybe already pre-formed total trihalomethanes, haloacidic acids. So then they have to do the BATs for consecutive systems. What's EPA and DNR2? The government loves these acronyms. What does BAT stand for? It's best available technology. So best available technology. So what would be best available technology for someone who's buying, let's say, all water from another system? What can they do to improve their water quality? They don't have a treatment, well, theoretically, they don't have a treatment plant. If it's been treated, it's already been treated by the first system, the wholesaler. And they get this product that might be questionable, might not be the best quality. So there are some things you can do in a distribution system. Flushing is one of the things that we tend to say. Flushing, because lines can have buildup of stuff, scale, and things inside the line, biofilm, some organic substances that when they meet up with chlorine will just raise the level of total trihalomethanes, haloacidic acids. So flushing to try to remove those things from the system. Tank mixing and aeration. Mixing helps try to prevent what they call thermal stratification. Thermal stratification, like warm air that rises, warm water rises. So imagine in the heat of the summer, when the sun's beating down on a water storage tank, that metal tank's taking a lot of heat, and transferring that heat into the water. The water sitting there overnight is warming, and been there all day, it's getting warmer and warmer. The water that first is newest coming into that water storage tank is cooler. So that water is denser. So it's gonna stay low. The warmer water is gonna make its way up to the top of the tank. Well, down at the bottom is where the water exits the tank. So the newer water comes in and goes out, comes in and goes out. The older water just sits there and gets warmer, gets older, over time dissipates its residual chlorine, so it's losing its chlorine, its protection against coliform. It's potentially becoming an incubator for coliform at the top of that storage tank, while the fresher water is coming in and exiting. Seems like not so bad a deal because you got fresh water going to customers most of the time, but imagine if you had a big water main break and all of a sudden that tank dropped. You might get coliform into your distribution system. And it's not just coliform, because this particular topic is about disinfection byproducts, that the longer chlorine and organic substances are together in water, the higher the formation of total trihalomethanes gets. So we're talking that could just get worse and worse. So mixing a tank to try to keep it always in movement, they have these slow mixing kind of devices, so that if there is sediment at the bottom of the tank, sometimes mineral settles, sometimes you have residue from treatment processes, and you get a little slurry at the bottom of a storage tank. You don't want all that brought up in suspension in the water. You want it to kind of settle, but you want the water to kind of stay slowly, gradually in motion to keep the warm water from migrating to the top. Keep it always mixed, so we don't have that thermal stratification. And then aeration. They do have bubbler aeration systems inside storage tanks now as one optional addition to storage tanks. And the reason they do is there are 4 total trihalomethanes. There are 4 of the total trihalomethanes. One is chloroform. Chloroform is the lion's share, for the most part, of our trihalomethanes. It is volatile. And I always say volatile means it doesn't want to be in water. It wants to release to the air, to the atmosphere. If it's a gas, a volatile gas wants to release to the atmosphere. And that's what chloroform is, a volatile gas. If it's a volatile contaminant that's not gas, like petroleum, well, we know petroleum separates from water and will float, or oil will float on top of water. It too separates from water. So anything that's volatile tends to separate from water, and a gas will separate and be dispersed in the atmosphere. And that's what these aeration systems do by trying to release that chloroform. So those are methods that some systems employ to try to improve their disinfection byproduct formation, lessen their total trihallomethanes in their system in that. So factors that affect byproduct formation, the amount of organic substances that are in the water, the disinfectant, chlorine, forms total trihallomethanes, haloacidic acids. Those are the two groups that are regulated right now. The water temperature, the warmer the water, the more organic life abounds potentially in the water, and therefore the more, you could say, of organic ingredient mixing with chlorine to form trihallomethanes. Biodegradation of haloacidic acids. What they have found after research, it was pretty hard to predict HAAs based on total trihallomethanes. They seem to move in different directions. So they did find that initially, right after you inject chlorine, your HAAs are really high, but over time they tend to deteriorate and drop off in concentration. Just as trihallomethanes are curving up and becoming worse with time. So residence time is a definite factor. The longer water sits with organics and a disinfectant in it, the more formation possibility there is, especially for total trihallomethanes. So prescribed treatment for surface water, groundwater under the influence of surface water, those subpart H systems in the federal regulation. Enhanced coagulation is one of the prescribed methods from EPA. And simply what they said is, let's not guess about things. Let's go in and raise our primary coagulant, the chemical, the metal, that we use with that positive charge to bond with the negative charged organics. Let's raise the dose by 10 parts per million and see what that does to our pH. It should bring our pH down. And if that doesn't bring it down enough, then let's raise it again another 10 parts. And if that doesn't work, let's raise it again another 10 parts. They just use 10-part increments on the coagulant and get the pH down, ideally between 5.5 and 6.5. They did go as high as 7.5 if you have real high alkalinity in your source water. Alkalinity neutralizes acids, so therefore it's going to combat and be counterproductive in the process of trying to lower the pH. So sometimes you have to go up higher on your pH. But the process would ultimately then convert soluble total organic carbon, TOC, to insoluble particulate. And if it's a particle, it can bond with the metal, the alum, or the ferric that we use, and be removed. Add weight and through gravity drop out in our treatment process and be removed in our filtration as well. Or the opposite. We can do the opposite with our pH. We can raise the pH way up. So we can go either extreme. We can, if you're already softening, and some surface water systems are softening their water, but just not quite going high enough. Some of them go to 9.5 to 10. And they really just need to go up to the upper 10 level, I usually say 11 pH. And what they'll create is manganese dioxide. So naturally occurring manganese forms this gel-like substance that actually helps, because of its positive charge, attach to negatively charged organic substances and then removes them. So either way, we're using a metal. In this enhanced softening process, we're actively using what's already naturally existing in the water source to improve the process of removing organics. The more organics we can remove, the less formation of total triethylamethane haloacidic acids that we will create. So the pH, the target pH in water is determined by the alkalinity of the water. Again, the higher the alkalinity, the harder it is to suppress or lower the pH, because this is a buffering against acid, so it's harder to bring the pH down. So systems take a paired sample, one source water sample, one treated water sample, and that's for each plant. Source water is prior to any kind of chemical oxidation, and it's for the total organic carbon and the alkalinity. Treated water is our combined filter effluent for TOC. And then each month, the required removal of TOC is kind of a moving target. There's a percent removal that systems have to achieve. There is a reduced monitoring which says that if the average annual treated water total organic carbon is less than 2 milligrams per liter in 2 consecutive years, or 1 in 1 year, system can be reduced to 1 paired sample for each plant quarterly, per quarter instead of monthly. So they do have some reduction there. Here's the moving target, though, for removal of TOC. Our source water's level, they give you ranges, and our source water alkalinity, 0 to 60 milligrams per liter, greater than 60 up to 120, and then greater than 120. And you'll see it goes as low as 15% removal up to 50% removal, depending on where you fall here. So from 1 month to the next month, your percent required removal of your raw water, untreated source water, total organic carbon can change in terms of what your requirement is for removal for this treatment technique. They do have some alternatives. I'll just run through these quickly. The alternatives for total organic carbon removal, any one of these, if your source water TOC is less than 2, or your treated is less than 2, or SUVA is less than or equal to 2 on source or treated, and SUVA is specific ultraviolet absorption at 254 nanometers. So what that is saying, this SUVA test is actually doing a couple of things. It's testing what is aromatic organic substances. Aromatic organic substances are the ones that are most likely to bond with chlorine to form total trihalomethanes and haloacidic acids. So it measures those. That comes from the UV254, the ultraviolet absorption. Those are the ones that will absorb ultraviolet light at 254 nanometers. And then it measures the total dissolved organics. And it'll take the aromatics and divide them by the total organic content. And that fraction, if it's a high level, will tell us we have a high level of formation potential in our system, because there's a lot of these aromatic species in our organic matter. Or maybe the other way around. Maybe there's only a little bit. But that's part of the process of determining what our formation process is. There is an alternative to removing TOC, and if our source water and treated on a running annual average is TOC is less than 4 milligrams per liter, our alkalinity is more than 60 milligrams per liter, and our total trihalomethanes and haloacidic acids are at half or less of the MCL. If all of that's true, then you're allowed to be exempted from the removal criteria that you have to do on a monthly basis. So monthly TOC results satisfy minimum percent removal unless allowed reduction, or fulfill alternative compliance criteria. Failure to achieve sufficient TOC reduction otherwise is a treatment technique violation. So you might be in compliance with total trihalomethanes haloacidic acids, those MCLs, and still not have removed sufficient total organic carbon and have a treatment technique violation that you'd have to tell your customers about. That's a Tier 2 public notification. Tier 2 means direct distribution to our public within 30 days of being notified. And then there is a operational evaluation level report that some systems were sent. And basically what they do is they have to calculate our 2 prior quarters results, take those numbers for each location, and the most recent results for each location times 2. So, and then you add them, you got 4 numbers, and then you divide that by 4. That tells us if we're on a collision course with the regulation. If it looks like we're gonna be maxing above the MCL, maximum contaminant level. And the report, the operational control report, operational elevation report is basically just almost a survey, asking, okay, what's your source water? Are you buying water from somebody else? If you're buying water, is there a sample site right at the master meter? Really would be helpful for any system that buys its water to know that, to know what is its total trihalomethanes haloacidic level right there as it comes in. That would tell us then, with our result in our system, how much higher did it go? Is there a big problem in our system for lack of turnover of water, maybe dirty lines or something? Or is most of the problem the high number coming in right from the wholesaler? So that it's a nice device just to go through detailed questions so that a system can help identify the problem and maybe help lessen the problem. It goes into a lot of detail that I won't burden you with here, especially since nobody in this class really deals with trihalomethanes haloacidic acids. It goes through not only a lot of questions about issues related directly to your system or to the wholesaler, but it also even asks things like, have you sat down at a table and talked to your wholesaler and try to see if you both can resolve the problem, which is a real good thing because sometimes you don't have very many options if you're receiving water that's already high in disinfection byproducts. So I'm not going to go through all that detail, so I'm going to whip through that kind of quickly. Any questions about this topic? I know this doesn't affect you, but any questions about it? Okay. Well, I've got 9:35. There isn't a big clock on the wall, is there? Can we take a 10-minute break and get back at 9:45?
We can bump you a little bit here.
Well, talk a bit about radionuclides in drinking water. We do have some systems in Missouri that struggle with this. I don't know if anybody in here does. You guys do? You guys do?
You gotta say radon?
Yep, radon,
Okay.
radionuclides.
Our subdivision service has that.
Is that right? Yeah, quite a few systems tend to have it, and around here it seems like it's pretty common. And they're other places in Missouri where those numbers are high. So radionuclides cause ionizing radiation, particles radioactively decay, cause chronic health risks, typically cancer again. Uranium also causes toxic effects to kidneys. Most water sources in the United States have very low levels, and at low levels, it's not really considered a public health threat. Most of the United States, very low occurrence of average radionuclides, but part of the Midwest has some higher than average combined radium-226, 228. Some have elevated average uranium in western states. Other radionuclides are not usually found in drinking water sources. The more common ones are radium-226 and 228. Drinking water, human-made radioactive contaminants. Drinking water might have it if there's a facility that has an accidental release or improper disposal of human-made radioactive materials. Primarily facilities that use, manufacture, and dispose of those substances. Exposed water systems must conduct extensive monitoring, and the typical radionuclides that are found that are human-made come from human-made sources or beta particle and photon emitters. The purpose of the radionuclide rule is to simply reduce the risk of cancer primarily. It retains existing maximum contaminant levels for combined radium-226 and 228, gross alpha particle, and beta particle and photon activity, and it regulates uranium. Who's affected? Right now, it is only community water systems. However, there is possibility that in the future it will also extend protections to non-transient, non-community water systems. So those are schools and daycares, nursing homes, churches, factories, those places where you don't live, but you do go back every day, basically, either work or go to school in that. So the regulated substances, the MCLs, beta photon emitters, we have MCL of 4 millirems per year, and I don't really know what a millirem is. I'm used to good old parts per million or parts per billion. So gross alpha particle, 15 picocuries per liter. Also don't know what that is. About that much maybe. I'm just making that up. Combined radium-226 and 228 is 5 picocuries per liter, and uranium is 30 micrograms per liter or parts per billion. At least that I can kind of wrap my mind around a little bit. 1 part in a billion, so 30 parts in a billion. The health effects language that comes from our regulation, combined radium-226, 228 is naturally occurring in some drinking water sources. And then just to read this verbatim, some people who drink water containing radium-226, 228 in excess of the MCL over many years might have an increased risk of getting cancer. And then you'll see the language pretty well stays the same. Gross alpha, naturally occurring. Some people who drink excess water with excess gross alpha in it get an increased risk of getting cancer. Beta particle, photon radioactivity, same thing. If you drink it for a number of years, elevated levels above the limits, you have an increased risk of getting cancer. Uranium is the one that, in addition to cancer, it does list that too, but you will have a risk of toxic kidney effects. So sampling location for radionuclides or entry point to our distribution system. the contaminant, and here's the monitoring schedule typically, or frequency for monitoring. All of the substances, gross alpha particle activity, uranium, radium 226, 228, is to be monitored, sampled for every 9 years, really, every 9 years for contaminants. That assumes that we don't have any detectable limits on any of these. So 9 years is what I'm going to say the typical frequency. But if we do have any of these elements detectable, but within half the MCL, so half the MCL or less, and detectable by the laboratory, then we increase the frequency down from 9 years to 6 years, every 6 years. And that would be for any one. Let's say uranium is one that falls in this limit. It would have 6-year frequency. And if the other ones were not detectable, they would have a 9-year frequency. Then if we exceed half the MCL but are still within compliance, then our sampling frequency is every 3 years for any substance that falls in that range. And if we're above the limit, then we go to quarterly sampling for each contaminant that exceeds the maximum contaminant level.
Doesn't that seem like a really long time, 9 years?
9 years, if you don't have it in your water, it can be a long time, but if you don't have anything detectable by the lab in your water of any of those substances, then it's probably meant to be more economical. Why test the water every year if it's not even showing any of these threats to the public?
Tom?
Yes.
These radionuclide samples are expensive.
Say that again, Steve.
These radionuclide samples are expensive to do.
Are they?
Yep, they have to come to the health labs out of Jeff City, and there's certain kind of samples you take. And they're very expensive to do.
Ours has to go through San Luis County Health Department.
Ours has to go through, state has to go through, state and Farmington has to go through the health lab in Jeff City.
Is that right?
Mm-hmm.
And I thought ours here went to St. Louis too.
What's
Did you
your
say that?
Yeah.
Because,
So that
And the
might
strange
be
thing about it, we're on quarterly because we jumped back up again. And we'll get a sample every 3 months, sample, box, cube tank. It takes about 4 months to get the results back. You get your next sample before you get the results of the one you just took.
Is that right? That takes that long.
And that's quicker than it used to be.
And that's coming from what was it?
San Luis County Health Department.
St. Louis County Health Department doing that. And do you know off the top of your head which one it is you're sampling every 3 months?
Radium 226 and combined alpha,
Okay, both of them.
we're out of compliance on both right now.
Is the state offering any remedy?
We found out the other day we're gonna get the new system. The funding's gonna be available for us to get the new water system. In that project, they included to revamp our treatment plant. Well, we core sampled those filters back some time ago, sent that off to Filtronics, and they got to send a report back saying there's no active media. So, we're gonna have to replace the media in the filters. But there's some friction there because technically that treatment plant never was approved the way it's running by DNR. So,
And what are you treating for? I mean, I know you
radionuclides.
got
But
radionuclides,
the original plant was set up, the Filtronics filters, and it was set up to run ferric chloride with chlorine to filter it out. And then the backwash is into the backwash, which goes through the, it's really strange. We try and take radionuclides out of drinking water and turn around and put the water back in bigger. Yeah, anyway. The ferric never did work. So they had an engineering firm, Metropolitan, came in and there was a new, this was back some years ago, it was a new process called a Valentine study or Valentine something. Anyway, this guy, instead of treating with ferric, he treated with manganese sulfate. The manganese and the chlorine will combine and attract radium and get trapped in the filters. So, it's what Bonterra's doing now. It's what they call an HMO plant. The manganese and the chlorine make hydrous manganese oxide, which will attract radium. That's supposedly how it works.
Okay, so hydrous, say that again, hydrous manganese oxide?
Yes. By mixing manganese sulfate and chlorine. You inject those at the same point before your detention tanks into the raw water. Then they mix, make the HMO, which attracts the radium, which is trapped in the filters.
And do you know how well that's working now for them?
It worked really well for us. Supposedly it's working really well for Bonterra, because Bonterra has bigger problems than we do with radionuclides. And supposedly they're back in compliance now.
And you already have that media in place, and you say it's working?
It was working. Then we found out that the media is going out of the filters. So we're in the process now. If we can get an engineer to sign off on it, we're just gonna order and put new media in the filters, go back to treatment the way we were, if we can get DNR approval and everything else.
They got that in Wesley.
So what happened to the media?
They say, I don't know if it's all washed out or if it's just not active anymore. Those filters were put in 1997.
Okay. So, and that's how long the HMO's been in place?
No, they first started treating with ferric,
That's what I thought, ferric, okay.
and that didn't work.
And how long has the HMO been online, do you remember?
I don't know.
Been a few years, or?
Yeah, it's been a little while. I don't know exactly how long.
I think it was in compliance for like 3 years.
We were in compliance for a few years, yeah.
Yeah, I think it was 3 years. It's a Tom O'Connor deal.
Yes.
And I believe they say the media is only supposed to last for 5 years.
Right, but
Oh, all
now,
right.
the new media, it's called Electromedia One. It's a proprietary thing through Filtronics out of California. The literature on it now says it's lifetime media. It's supposed to last 20, 40 years. I don't believe a word of it, but that's what it says.
And that's what you're getting, what you're gonna be getting
Yeah.
when they replace it?
If everything works out, that's what we're just gonna replace the media and the filters. Go back to, because we're not adding manganese now, because there's no filter media to trap it.
Yeah,
That would just raise the manganese level in your water. So
right.
It's a bit of a struggle right at the moment.
Yes, Jim?
But his dilemma, to take it a little step farther, his dilemma was that it was never approved by DNR to start with. So now they have to go through all of the approval process because it was not approved to start with. So now they have to prove this, so the engineer has to prove it's gonna work before they can go on.
And we just had an inspection a couple, 3 weeks ago, and everybody from Poplar Bluff was up there. The engineer and Jack, but the whole bunch was there. They wanted to see the treatment plant because of this problem. And I was told by Jack Baker, he said there was a person, and I don't know the man's name, that worked at Poplar Bluff at the time. And he signed for him to go ahead and use that procedure, but it never actually had full DNR approval. Now, how that came to be, I don't know. That's what I've been told. So, the mayor met with our engineer now, Tim Robbs, yesterday, because Tom O'Connor is the engineer who designed the plant, with that plant. Because we're under contract with an engineer, because we're getting this other system, he went and met with him, number one, to see if he would sign off on it. I said, no, he's not going to sign off on it. Something another engineer did, and he wouldn't. But anyway, he wouldn't have a problem with the city talking to Tom O'Connor and see if he'll sign off on it. The only problem with that, from what I understand, he's not on DNR's approved list of engineers.
I didn't know if DNR had an approved list of engineers. There's some big on engineers, I thought they just had me.
Apparently, they have a list of approved of engineers they will accept. And apparently, he's not on that list, from what I heard. I don't know.
Yeah, I didn't know that.
Since we're talking about samples here, does anybody have any trouble with the county health departments taking samples?
And you all take your, now we're talking about the revised coliform rule, taking your bacteriological sample
Yes.
off, dropping it off for the courier?
Yeah.
Anybody having trouble with
The
that?
only problem that we had, we used to use that service, and we quit. We went to our local place, EAS, the Jackson Environmental Analysis South.
Okay,
Yeah, but I still
Yeah.
gotta ship stuff
Yeah,
to
but that
from the
doesn't come
county
in
health,
that.
like on the nitrates and lead and copper and
Yeah,
other
that
stuff.
doesn't come under that 30-hour rule.
right, yeah, this would be the
Well, I
total.
have a lot of customers that use that, it's a free service. But they always take the sample from a mixing faucet.
Yeah. Yeah, the customer probably is not the best person to take your,
Well,
Your sample.
this county comes out and takes it.
oh, okay, it does.
They come out and take the sample, and then the customer calls me and wanting to chlorinate the well.
Hmm.
You know,
Have you had trouble with the courier not getting it to
well, they didn't know,
the lab?
that's- I don't know what their process is, you know. I don't know if they get it there in 30, I think it's 36 hours, 30 hours.
Yeah, 30. Through the
30
years, I've heard issues, some related to concerns about that, but not many with all the systems that we interact with that I can recall that have had trouble with the courier. And that, most of those were a few years ago, and I think they were still trying to line it all out in that.
When we've had our well inspections, we have never had a sample taken that made it to Jefferson City in time. And it was sent by people from DNR.
Is that right?
That's why I like the way we got it set up. I take the sample to where it's going to be tested, and it's with me until I hand it to you.
Right to the lab, and you're doing that lab.
And then I get the
Right.
results the next day. If there's a problem, I'm already working on it by the time I tell you there's something wrong.
Yeah,
And
yeah,
that's great because you may, like he said, you may not find out till you already had another sample done 45 days ago, the first one.
Do
exactly.
you remember when you used to have to send it to pop the blood?
Yeah.
Oh, my gosh. You'd have to do they even do that down there anymore?
Not anymore.
Yeah,
That lab is,
There was so many problems.
yeah, that lab is shut down.
I want to make a remark on the
Yeah.
level sheet. More and more of the new oncologists that's coming out of school, where they find significant cancer rises or renal failure from some reason, are paying more and more characteristics of the water. They're really studying that.
Are they looking more in?
Because it's a known fact, you'll die without water, but you can die with it.
Yeah, yeah,
Bad water is bad news.
yeah.
we got good.
Yeah, sometimes those levels are high enough that they can be a concern for our health.
Sure
Uh,
can.
There are different schedules DNR looks at to determine what the frequency will be for a system. The results of its reduced monitoring will determine future sampling frequency. As an example, if a system has less than detectable limits, it's gonna have a 9-year frequency. But a system that, say, has some of the elements between detection and half of the MCL or half the limit, somewhere falling in that range, then they're gonna have a 6-year frequency and so forth, or for some of their testing it will be. We can see that sometimes we increase to monthly. So a system that exceeds the MCL for beta or photon emitters, and it will be reduced from monthly to quarterly sampling if it has 3 months consecutive in which the numbers fall below, within the limits, the MCL. So compliance is quarterly or monthly sampling based on a running annual average of each sampling point. And if the average result exceeds the MCL, then that triggers non-compliance. Also, it's non-compliant for a system, I should go back, jumping ahead too far quickly. Any sample result at a single sample point causes the average to exceed the limit for the MCL. If you're collecting more than the required number of samples, and I don't know, maybe somebody would do that to try to bring the averages down. All sample results will determine the compliance, and if you're collecting fewer than required sample, then the running average of the samples that are taken will determine your compliance. So even doing fewer in this sense could go against you by having less to, in a sense, dilute it down or help average down your samples. Treatment options, and actually, I don't know that in my list I have something so updated as your HMO media, hydrous manganese oxide. I actually did have a conversation with the operator there at Von Terre, who told me they were going to go to that a while back, and I'm glad you brought that up because that reminded me of that. Hydrous, because he used the same letters, HMO, hydrous manganese oxide. Let's see if that's in this list. So one thing they show that easy, relatively so, and easy to operate and manage is ion exchange softening. Usually don't even see those in a public water system, but that is effective according to the American Water Works Association at combined radium and uranium and beta particle photon radioactivity. They call that intermediate in terms of operational skill required. Reverse osmosis is advanced, and that's not very common, although we do have some systems in Missouri that use it. City of O'Fallon, and more close to us is, what's the name of that? Pilot Knob Rural Water. Doe Run, there you go. That system is using reverse osmosis for removal of their radionuclides. So we have, I want to see here, lime softening, green sand filtration, co-precipitation with barium sulfate, electrodialysis reversal. Was that something you mentioned back? Did you mention that? Preformed hydrous, here it is, preformed hydrous manganese oxide. There's your HMO filtration. Good at combined radium, but apparently not at any of the others. But combined radium was your culprit, right? That's the one that you guys.
And gross alpha, both.
And gross alpha, too? Gross alpha. Now it doesn't.
But when they were using that system before, and from what I understand from Von Terre, it's taking care of that too, because they were in compliance with it.
Is that right? Okay. Activated soap, aluminum soap, absorption, and coagulation filtration. Okay. Yeah, I don't think this is the complete story here. I do suspect that these are more effective than American Water Works Association gives them credit for removing more things. Some systems are using ion exchange softening for lead, removal of lead too, from their source water.
On that reverse osmosis, do they get the volume out of that system?
They say spent water, they actually have to produce more water than they're going to actually be able to use because they waste so much water from the reverse osmosis process. So, and they too, I think, are sending back to the receiving stream or creek. I don't think their water, their spent water for their at Doe Run.
On the ion exchange.
Yeah.
DNR doesn't recognize that as treatment though.
Well, when it is used for radionuclide removal, lead removal, then they do. Then they call that a treatment process.
Because we had a softener power plant, and they were industrial grade, 120,000 gallons per day per softener, and they wouldn't recognize the treatment. DNR.
Yeah, if you're just using it to soften the water.
Well, we was using it for drinking water in the power plant and boilers now, and they won't recognize it all, because we could have went through all the loop line system at their facility to soften the water, to get rid of the radionuclide. They wouldn't even discuss it with us.
Oh, they wouldn't even consider it as an option for that.
They said it's not considered a treatment to DNR.
Well, it is used in some places for
It's being
radionuclide.
used for that, yeah.
It is being used for radionuclide.
We know it works. We prove it works. When we took the water out of the softener, we proved it works. But because our wastewater for the softeners and the salt goes down to the Farmington treatment plant, they didn't want the radium and the salt down there, so they would recognize the treatment.
Oh. So in your particular circumstance,
Maybe, I don't know.
They
I don't know,
said-
it's just that.
they said no, they didn't want it.
Right.
Now, were you treating all of it or just part of it?
We could have done both. We were doing just part of it, but the facility we had the means to do the whole system. They wouldn't do it.
I know some places that are using it for treatment are just treating a small portion and blending it just enough to get it below the MCL.
Right. Well, see, we had the softeners in each one of the well houses, and DNR made us take them out and put these radium removal from Filter Tech, which made it worse, because they were junk. And then the city farm took over in WRT, and their system worked, but they wouldn't let our softeners even, they wouldn't even let our softeners do the treatment.
Wow. Well, that sound like that kind of backfire.
Yeah.
Well, that's really all. So I would say economics might be the reason for some of those long delay time frames in between when you don't have it in your water. The other thing EPA has gotten kind of more fine-tuned about is trying to target things that are more problematic for corrective measures and let things that are less problematic be less frequently monitored for. So, yes.
You know, since they've taken the the lead out of the brass,
Yeah.
they've had more trouble with brass fittings, getting hold of them.
Is that right? They're less malleable now because they have less lead in them?
Fitness adapters and valves and things like that. I don't know if it's because of the water in particular, you know, or just because they took the lead out, I don't know.
Yeah, so you don't know for sure if your water is aggressive.
Check valves, we're having problems with the check valves. And,
I could see that. Lead makes things more malleable, and
yeah,
if you
it's more,
can't,
it
if you
gets, yeah.
get rid of that, you got more rigid stuff that probably doesn't give. It's either
Yeah.
do or die. Well, that's an interesting observation. We're gonna move into that topic. Let's look at treatment options. We're gonna move into that topic.
guess
I don't know if it's the
I guess
next
that's too
segment here.
soon, then. Now I won't have anything to say about it.
Sure.
Yeah, there we go.
Lead copper, right there. So I was just gonna ask about any problems with lead copper. Maybe by removing the lead from some of the components we use, we've encountered some experiences with that. Anybody else have similar problems? What about lead or copper in your water?
We had a high copper deal in our water at Farmington.
Tell us about that. You were telling me on break, Steve.
On drinking water, there's not an excessive MCL for drinking water only. On wastewater, it's a 2 micrograms, 2 MCL on drinking water, on wastewater. If you got an excess amount in drinking water, your copper is gonna fall out as you run the water, and that's gonna go to your wastewater. And wastewater has a 2 micrograms per liter of copper. So if you've got a high level in drinking water, you're gonna get a violation on your wastewater. And we just found this out back in January. The state got a violation on it, and it came out of the well, which the city of Farmington is running. We had a washout. The well showed a 1,500 on the drinking water, and nobody caught it from the city of Farmington. And as it went, it just kept accumulating, and they got it, and DNR changed the wastewater rules, and they made it to 2 maximum on wastewater. And as it compounded, it went above the minimum, and they got a violation for it. This has just changed in the last year. So keep an eye on your drinking water. If you got are getting an excessive amount of copper in it, you might want to say something to DNR, because you will get a violation for it.
Because as it goes through the sanitary sewer system, it can influence and elevate your levels of copper.
Because they're gonna come back, they're gonna trace it back. They can trace it back, no problem now.
And wastewater, I can kind of understand that, because wastewater will influence fish, and we use copper sulfate in surface water systems to inhibit the growth of algae, and the high levels of copper could actually be toxic to fish in that. So I could see, because you're going to be releasing that water eventually to some receiving stream, that could increase the metal content of copper in that water, and might be toxic to aquatic life. You remember in drinking water what the action levels are for lead and copper? Anybody remember that really small number for lead? It's 0.015 parts per million. 0.015 parts per million. And for copper, it's 1.3 parts per million. There they are. So what happens if we exceed the action level for lead and copper? What violation occurs if we exceed those limits? Trick question. There is no violation. There is no violation. I was actually surprised, and kind of echoing what Steve said. There's no real limit. In drinking water, there's no violation, I should say. There is a limit. The limit is this: 0.015 milligrams per liter parts per million, and 1.3 parts per million of copper.
But it's not enforceable. But it's not enforceable.
Well, it's enforceable in the sense that they can take action because you have an action level exceedance.
Right.
And then there are certain things that kick in. And see, here are some of the triggers that are prescribed on what's called water quality parameter monitoring. I'm going to touch on each of these. Corrosion control treatment, source water monitoring and treatment, public education, and lead service line replacement. So talk a little bit about each of these. Systems that are affected by lead copper rule are community water systems and non-transient, non-community water systems, where the people are the same people every day using the water supply, whether they live there or they don't live there. Adverse health effects of lead: damage to the brain, red blood cells, kidneys, especially for children, young children and pregnant women. Health effects of copper: stomach and intestinal distress, liver or kidney damage. And let's just take a moment to watch a quick video. Let me see, did I get that thing? Oh, it's on here. I forgot. Well, I think it's on here.
Kind of makes you wonder how these older homes that had lead pipes in them, people kept on living.
Yeah, you're right. Yeah.
Town would have a bunch of lead lines.
Or they just didn't all die off.
Well, as EPA might say, it's all about the water and how corrosive the water is to strip that metal off to bring it into people's homes.
2 U.S. towns have now found elevated levels of lead in their water supply. Let's look at why this is happening and exactly what lead poisoning is. When you turn on your faucet, you're the final destination in a water droplet's incredible journey through regional and local water supply systems. That drop typically has gone from source to treatment plant to pump station to water tower to water main to local distribution lines to get to you. Here in the United States, a lot of that infrastructure was built immediately after World War II, and some of it even dates to the late 1800s. A few towns in America still have wooden water mains. According to the EPA, at least 30% of our high-use drinking water pipes are more than 40 years old. This aging infrastructure could be a huge problem for 3 related reasons. First, the CDC only started establishing acceptable blood lead levels for children in the 1960s, meaning that many of our pipes were built before we knew exactly how harmful lead is. Second, metal pipes, depending on what metal they're made of and the conditions where they're laid, can last over 100 years. Or as little as 15. And third, this infrastructure is literally buried, so it's difficult to diagnose issues until something has already gone seriously wrong, like in Flint, Michigan and Sebring, Ohio. All metals break down over time through corrosion and dissolution. That's right, metals dissolve, just very slowly. Water is corrosive by nature because it contains dissolved oxygen. And corrosion is what happens when metals react with oxygen and break apart into particles of metal oxides. This is disastrous for human drinkers because lead is so toxic. Even at seemingly tiny levels of ingestion, it can cause irreversible damage to the liver, blood, kidneys, and brain. In young children and unborn babies, it's been implicated in lifelong behavior and attention problems, reduced IQ, delayed growth, and even an increase in violent behavior. Although researchers are still studying why these effects happen, the leading idea is that atoms of lead displace other atoms in proteins. This can seriously reduce or change enzymes efficiency in our bodies, causing chains of issues from the cells up. Steps can be taken to preserve pipes by controlling water's pH level and adding protective compounds like calcium or magnesium salts that will coat the pipes and won't harm humans. But every water system is different and must be monitored closely, and these are all temporary measures. A report from the American Water Works Association suggests that updating our water infrastructure will cost $1 trillion over the next 20 years or so. But this is one of those cases where the cost is unavoidable. And as Flint is finding out, not making needed updates is much more expensive in the long run. So what do you think should be done about all this? And hey, on a lighter note, what do you think about our new studio? Reach out and let us know. And to learn more about what's going on right now, visit now.howstuffworks.com every day.
All right, so just a little presentation there. Let's get back to this. So sampling, first draw. So what are first draw samples? How long do they sit at minimum before we take water from the faucet?
6 hours?
Okay, good. 6 hours is the minimum and 12 hours is the maximum. We want water to sit in that line for 6 hours. We typically ask customers who are doing the sampling for us in their residences to wait to first thing in the morning. Before you do anything, you get up, before you turn that faucet on for anything else, open it up and fill those bottles. Tiers, we have different tiers, and the tiers we use for lead sampling sites are Tier 1. The Tier 1 sites are the highest priority ranking. Those are single-family residences with lead pipes or copper pipes that have lead solder that were installed after 1982 or that have lead service lines on them. Tier 2 sites, and I'm not sure why this is a secondary priority, are multi-family units, like an apartment complex, with either lead service lines or lead plumbing or copper plumbing with lead solder in them that was installed after 1982. And then the low priority Tier 3 site are single family homes with plumbing installed before 1983. So those are the different priority rankings that they give us for these. Other sampling considerations. What about this? Are sites with in-home softeners or faucet filtering devices acceptable sampling locations? All right, I see you're saying no. I agree. Softened water's corrosive, and filters remove or lessen lead and copper, kind of stilting the results a little bit, skewing the results some, right? What should customers do with faucet aerators before collecting samples?
Take them all.
Okay.
But the only mixing faucets usually have aerators.
Yep, they do. Yeah,
So
yeah.
that's an unacceptable site.
Yeah, or almost any faucet, even without the filter, you're right, that would be unacceptable.
Yeah.
Have a little aerator or screw threaded piece on, a little screen on the end of the faucet. And no, the interesting thing is they've changed the lead copper rule a time or two since it's originally come out. When I was in the city of Fredericktown, working here, the rule said, according to EPA, the rule said that you should tell customers to remove that area because little sediment that gets built up in there can actually, again, skew the results and cause a higher level, tilting it toward excess lead or copper in your line when it's not really about the water, it's about that little sediment trapped there. Now, they say the opposite. They say, no, you should leave that in place. And I'm guessing the thinking there is, this is typical of what the customer drinks. So even if that skews it, it is still true to what the customer is drinking from that goes through that little area. So they say now, leave that in place.
That's what the county uses as an excuse to take it from the kitchen sink. That's where you use your most water.
That's where you use most water, where you're gonna drink most of your water, isn't it? Yeah. Probably not gonna drink it from the bathroom faucet so much, you're gonna have a cup or glass there in the kitchen, drink it, probably. How long should customers flush the tap prior to collecting their samples?
First water that comes out.
Say it again.
First water that comes out.
First water that comes out. You're not supposed to flush, right? You don't want to flush. You're deliberately leaving the water sit in the line at least 6 hours to see if the water itself is maybe etching out a little bit of lead in those service lines or plumbing, in the household plumbing. What about household outside hose bibs? Are those okay?
Not if they're frost-proof.
Okay, frost-proof, we're thinking in line of the bacteriological samples that can be contaminated, right? But what about for lead copper? Would that be, what about for lead copper? Lead and copper
I
samples?
would think it could be used.
I don't know about that.
They don't want you to use them because they aren't intended as drinking water taps.
No.
Usually you've got a garden hose hooked up to water pets, or water a garden or whatever you're doing with it, wash a car. They're not really intended for you to drink the water from there, so they want to kind of steer things toward what's really likely going to be something I'm consuming. And it's going to come out of typically that kitchen faucet, isn't it?
Yeah.
Now, we're back, now we are right on where you had talked about, say your name again, George?
George Keeler.
George.
Yeah.
If you remove a meter, valve, or other component that was installed prior to the 2014 Lead Reduction Act in drinking water, are you allowed to reuse it? Remember that rule?
I wouldn't think so.
Okay, you're not allowed to reuse it in another location, but you can take it out and put it back in that same spot. So if you were, say, there was a home being rented, and before this date happened, you removed it because the renters moved out, and now it's sat empty for a while, and you've got that meter and it's still functional, you could go back to that same location, put that meter back in. Even though it predates that rule, they didn't require you to just trash those meters or any other component. They said you could put it back in, as long as it's in that same location. I would say if you're going to do that, definitely, if you're going to set it on a shelf for a while, you want to take apart those meters because they get mineral in them, and boy, that mineral frees up a meter. It just sits there on a shelf, and it won't even turn 3 months later or 6 months later, you know. What did the Lead Reduction Act in water reduce allowable levels to? That went from 8% allowable lead in components to 0.25%. So from 8% all the way down to 1/4 of 1% lead. And does the act include fire hydrants? Remember that? Did they include fire hydrants? They did originally, and then they excluded them. Because, once again, we don't typically think of a fire hydrant as a source for drinking. So, since they weren't intended as someplace where you go if you get water to drink, they exempted hydrants from that rule. Okay, so criteria for triennial monitoring. That means once every 3 years, that's what systems typically do, is once every 3 years we collect our lead and copper results. Results that are within the action levels, ALs there, for 3 consecutive years, or other qualifying results approved by the state, means that systems will typically take their samples every 3 years. How do we calculate the 90th percentile? Because we're basing our compliance with the action levels based on the 90th percentile. Anybody know how to calculate 90th percentile? Where do they come up with a number? I came up with a formula here. Sum of all results, 4 times the square root of pi, divided by 3 in circumference, then extrapolate a value between 131 and 496. I just said something that sounded highfalutin. I don't even know what it is. Bunch of garbage. And I was just trying to scare people into think, oh my goodness, we'll let DNR figure out the 90th percentile. No, it's actually not really difficult. If you are collecting fewer than 5 samples during that sampling period, then the highest result is the 90th percentile. Whichever location had the highest level, that's your 90th percentile. If you have 5 samples, so that's fewer than 5, if you have 5 samples you're collecting, the average of the 4th and 5th highest, you take the 4th and 5th highest results, add them together and divide by 2. That average is your 90th percentile. If it's 10 or more samples that you're collecting, you multiply the number of samples you take by 0.9. So 10 times 0.9 would mean the 9th highest, and I'm saying highest, not 9th lowest. So not the highest, the 2nd highest result would be your 90th percentile, is how they do it. So that's how they figure that out. Sampling schedule, look at that thing, gets our eyes crossed, there's so much in there, but for small systems, we have some 501 to 3,300 systems in here. 20 is the standard and 10 is the reduced amount. There's some medium here between 3,301 and 10,040. That was, I know, City of Fredericktown, 40 but 20 was our reduced number. So, did anybody know off the top of your head, do you take 10? Do you take 10? What do you do at your company? You know? It's so infrequent. Every 3-5 years, you might not remember that.
We went through that initially when we put in the system 3 years or so ago,
Okay.
and, well, 2 years ago. So really that hasn't come back around.
Oh, okay, so it might be a little bit,
We're the smallest.
you're way down. So,
Yeah.
because your population is your employees,
Yeah.
right? And how many
Less
folks?
than 40.
Less than 40, okay. Okay, so 5.
Would you even have 5 sample points?
No. No, we don't.
So they might make exceptions for your circumstances.
When-
Sometimes what they'll do is they'll just tell you to take 5 times the volume in a single sample from a sample.
Basically, when I get things like that and they talk about the number of 5 sample sites, I'll just get on the phone and call, and they usually work with me and say, well, and they'll look at our system setup and they'll say, just take here, here, and here, or whatever. So, one from the well, and then a couple from, one from the maintenance building and one from the administration building, and they're okay with that, so.
That's
But I always ask for guidance.
That's good.
Yeah.
That's a good way to do it.
So,
And DNR is real good about adapting the rule that seems pretty easy to interpret for a municipality or a district to individual circumstances.
I've known Brett Ledbetter down at Poplar Bluff for years and years and years, and he's usually the guy that I start with that kind of puts me in there. If he doesn't make the decision, he'll put me on the right track to somebody to guide me
Good.
along that. So it's worked out really, really well.
Well, that's good. It's nice to have those channels of communication open.
I've always had trouble with pie. And on algebra, there's pie or square, pie.
I never liked that.
Well, and the good news is we won't have to worry about it at the end of this class. Don't ever go to my certification class, because we will deal with it pretty extensively in those. Consumer notices about lead. One of those changes over time has come down is that now we need to notify the household, the owner of the home, people who live there, where they collect the samples, what our results are. Before it was a courtesy, you might have done it, but you might not have thought to do it. So now they want you to do it, make sure to do it. How soon must you notify customers whose tap was used for lead copper? That's a 30-day time frame. Must also post information about lead in drinking water in your annual consumer confidence report. When does that come out?
July 1st.
Once a year? By July 1st, right. Both consumer notices are requirements regardless of your results. So no matter how low the levels are, you still tell the customer whose tap was used for lead and copper sampling what the results were, and you still put it in your consumer confidence report regardless of how low the levels are. Within 60 days of exceeding your lead action level, you have to issue a public notification regarding the health effects. I showed earlier the health effects, the risks of lead, the sources, and the steps to minimize exposure. The source might be the drinking water source itself. In some cases in Missouri, that is the case. Other instances, and probably more common, it's lead service lines or lead plumbing or copper with lead solder or fixes, fluxes in it, that are the problematic sources. Public notice methods for consumers for a community water system would be the water bill. That would be a way to get the word out. Provide press releases to at-risk populations. So who would be considered at-risk population?
Infants and elderly.
Okay, good. Infants, and I would agree with the elderly, infants and also pregnant women, because of fetuses in small children are real prone to the threat of lead poisoning. Use health department and other assistance agencies to reach these populations. With DNR's blessing, public posting for some small systems and for non-transient, non-community water systems where people are not living, posting publicly, distribution to water consumers, or if DNR allows, electronically. Repeat notice quarterly on the water bill or twice a year, especially to the at-risk populations, annually otherwise, especially as the problem persists until the system gets within the action level for lead, again for copper, not required. If the system's 90th percentile exceeds the action level for copper or lead, then the system is required certain steps in water quality monitoring. Temperature, the pH, the alkalinity, the temperature is only the first round of sampling they have to do. Conductivity, initial monitoring. Calcium is limited to initial monitoring for systems that use, systems that have calcium in the water, unless they have a calcium carbonate stabilizer. Orthophosphate, if the inhibitor in the water used is an orthophosphate-based product or a phosphate-based product. And silica, if the inhibitor against corrosion is a silicate-based product, then they still have to do that too. The frequency for water quality parameters at the entry point to your distribution system. You sample for pH every couple of weeks. Water quality parameter monitoring every 6 months. And reduced monitoring is allowed if the system meets optimal water quality parameters that DNR would identify on a case-by-case basis for a given system for 2 consecutive 6-month periods. So they do have prescribed time frames to meet those quality parameters and then have potential reduction of your testing. Source water sampling and corrosion control treatment. If a system exceeds the action level for either lead or copper, system has to resample within 6 months at each entry point to the distribution system, and that'll help determine the source water contribution to the lead and copper. So that seems to be a very sensible thing. We want to know how much is influenced by the source itself. State can require a study conducted within 18 months. State sets the maximum permissible levels for lead and copper in the source water. Source water sampling and corrosion control treatment. Continued monitoring for lead and copper every year for surface water systems, every 3 years for groundwater systems, and reduced monitoring is an option if you have low values for extended periods for DNR to determine when you can go to reduced monitoring. Corrosion control treatment installation time frame would be system has 24 months to install state required treatment. Follow-up sampling for system installing corrosion control treatment. Lead and copper sampling, water quality parameter sampling, and both during 2 consecutive 6-month periods. After follow-up sampling, the state determines the optimum water quality parameters. So they're going to kind of help determine what the best pHs and temperature and things like that that you're monitoring are for control of the corrosion. It's really a corrosion issue. Corrosive water leaches metals into the system, into the water, and then that comes out the faucet and people drink. So lead and copper are two metals that we are concerned about. Which water is corrosive? High or low, this is total dissolved solids. Water that has high levels of total dissolved solids or low?
Low.
It's actually high. High levels of total dissolved solids. It's the solids in the water that generate an electrical flow. And in the electrical flow, that's what is corrosive, the electrical flow of water. So what about hard water versus soft water? Well, now what I just said, all those solids in the water, the total dissolved solids. Hard water has a lot of them, right? And so hard water could potentially be corrosive, but usually hard water, what does hard water leave behind? Scale.
Yeah.
And scale insulates pipe or inhibits corrosion against the wall of a pipe because it's kind of protecting the pipe. So it's actually, hard water would actually be good where there is some remaining lead service lines, because it would provide a coating on the inner wall of the lead and prevent it from leaching out into the drinking water. So soft water has high levels of total dissolved solids, therefore making it highly electrical flow related and corrosive. What about warm versus cold water? Does that make a difference? It does. Warm water tends to make lead more soluble, dissolved, and carried off in the stream of water for customers to drink. So warm water is actually worse there. What about chlorinated versus chloraminated? Chlorine versus chloramines. Chloramines tend to be ammonia, I think, in the water with the chlorine. That's what chloramines are. Chloramines tend to be more aggressive when they encounter lead and tend to strip that lead and take it along in the stream of water. So chloramines are actually worse where lead is than chlorine.
I think you could tie those two together, really.
Say that
I
again.
think you could tie those two together with chlorinated water is just about as bad.
Chlorinated water
Yes.
can still be aggressive.
Yeah.
It can be, especially when we're talking about chlorine gas. If we're using that, it
Yeah,
tends
yeah.
to lower the pH of the water, and acidic water can be aggressive, corrosive too. I don't even think I have that in my list. Acidic water. What about these? Negative result on the Langmuir saturation index. Is that corrosive? Yeah, a negative number represents corrosive water. The bigger the negative number is, the more corrosive it is. When you get into the positive numbers, you're talking about water that's more about scale forming. A marble test result. When calcium carbonate treated sample has lower alkalinity than the blank. I always have to use both my hands to keep it straight here. If I take a sample, let's say this sample, I take two samples from the faucet, and I run the first sample through filter paper, and I run an alkalinity test on it. The second sample, I put calcium carbonate reagent in, and I agitate that sample and really shake it up to try to disperse the calcium carbonate in the water and get it dissolved as much as I can. And basically we do that agitation of the water every 15 minutes for at least an hour. We stop it, we keep doing that. Then we put that water through a filter and we run an alkalinity test on it. So we're taking 2 alkalinity tests, one straight from the faucet, one after we've added this calcium carbonate in. If the sample with the calcium carbonate is, let's see, what do I say here? Lower, has a lower alkalinity in than the sample without the calcium carbonate, what that means, it's lower in alkalinity, it is saturated. And what it will do is it will shed that calcium carbonate. So that means as this water travels through your pipes, it's going to leave scale, which is a good thing. It protects the pipe against corrosion. It's an inhibitor. So that will protect it. And then chloride exceeds 58% of sulfate concentration. I only discovered this a few months ago. Sometime last year, I read this. This is EPA's most direct method now, I think, of determining a water's corrosivity. You can go to your water sample results back at your system, if you've got them in a file. You can look at your IOCs, your inorganic contaminants, and they would have tested, the state lab would have tested sulfate and chloride. If you take your sulfate level and multiply it by 0.58, 58%, 0.58, and whatever that result is, if chloride is above that number, that's considered corrosive or aggressive water. So chloride exceeds 58% of your sulfates. Chloride can be a little higher than your sulfates, it's not a problem, but if it's more than 58% than your sulfate, more than 58, so it's actually, I shouldn't say it can be higher than, because I'm not doing the math right, am I? Not higher than your sulfate, but not more than a little more than half of your sulfate, and the water is considered corrosive. So that'd be an interesting thing to look at, just out of curiosity, when you get back to your systems, to see how your water is. Lead service line replacement. Systems continue to exceed lead action level after source water sampling and or corrosion control treatment. Determines which lines must be replaced through monitoring. So determination. Optional, one option that systems would have is to sample their service lines, and if the results come back within the action level, 0.015 milligrams per liter for lead, the line is considered replaced through sampling, replaced kind of through testing. But if you exceed the action level for lead, then the line has to be reconsidered. So partially replace lead service line requirement. If you're going to partially replace your lead service lines, so not all of them are getting replaced, but you're taking out maybe over a few year period, several year period, samples to determine impact to the lead exceedance. If you're replacing lead service lines, the trouble with that is that you can actually spike lead levels by replacing some of the service lines. So EPA's focus here is you should really look at the corrosiveness of your water and treat the water so that it won't be corrosive, and not tamper with existing lead lines if you're gonna only replace part of them, because you can actually cause levels to go higher by, I guess, breaking free some of this lead into the water. So their priority is more of a treatment strategy than a physical removal. But if you're going to replace, then they say to replace at least 7% of your lead service lines on an annual basis. And if only a part of your lead service lines are replaced, then additional action must be done. You must notify the customer 45 days before you replace the line, just because you're not replacing all lines, therefore the levels could go up, their lead levels. You must collect a sample within 72 hours of replacing the line and provide the customer the results within 3 days of your getting the results back. So there are some additional steps to take there. Any questions about lead or copper?
Is it, it's always, I'm sure EPA wouldn't care a thing about what I have to say. It seems to me that on the lead and copper testing, it's not so much a test of the water system as it is the plumbing in the house you're testing it. Because you don't test the water coming into a house, you test the water coming out. And we've got a lot of old houses in town. Think that we're okay on lead and copper. The only place that's a little bit higher is our wastewater plant. But to me, it's more of a test of the plumbing in the residences than it is in the water system.
Yes.
Yep. I think that's a fair comment. Or a test of the service line, because it could be potentially service lines too.
Could be.
Yeah.
And if it's a service line, it could be the water systems.
And if you've got a problem, I mean, you just have to isolate it, but it's just part of your testing. You'd want to test it where it goes into the house, not where it comes out. But I understand that, but the whole lead and copper testing thing to me is just.
I think what you'd want to do there is if a residence or several spike high on lead or copper, you'd want to go back and find out what that service line is. Find out if the problem belongs to the public water system,
Right.
and therefore becomes their obligation, or if it is primarily just the plumbing within the residence. If it's the plumbing, then it'd be good to be letting the customer know, hey, of course, we're going to be giving you your results within 30 days anyway. Here your results are higher than the action levels prescribed by EPA for lead or copper or both. You might want to consider replacing your plumbing in your home. And you're right, at that point, it's the customer's responsibility if it is. I'm working with a system up in northwest Missouri where the service line from the main all the way to the meter, all the way to the house belongs to the customer. The service line right from the main, they own everything. And the service line of all these many old homes in the older part of town are lead. And they have,
A lot of the gooseneck, a lot of them had the lead gooseneck connectors before the meters.
yeah, yes, right. So there's where you could, as a public water system, incur this issue that this is about your, or it could be, in this case, the customer's own all of the trouble. And what do we do about it? Well, the bias, I'm going to say bias, the primary approach from EPA through DNR down is to address the water quality that's causing corrosive action on those old lead lines instead of removing the lead lines. but to change the water quality at the water plant, which is what they're looking at doing now.
That's one of the problems that we've run into with this radionuclide deal, is everybody's scared to death we're gonna change the chemistry of the water, because almost all of our service lines from the main to the meter pits are still lead lines. And as you say, a lead line has a scale, and if you ever cut one apart, you actually see it. It has a scale in there, which I think is similar to what happened up in Flint, Michigan. They changed the water chemistry, caused that scale to strip out, and then lead to leach into the water. And everybody's scared to death to change the chemical composition of the water because we've got the lead lines.
Yes. Yeah, I can see that being a valid concern. I would certainly want a little information from the supplier of the media or filters, if anything's being changed, and it is, it sounds like, as to how does this influence the water quality in terms of our corrosiveness. Going through and removing things, you tend to cause water potentially to be more corrosive. Yeah, that's a great observation. Yeah, because you don't want to get out of the frying pan and jump right into the fire, do you? Free yourself up from the radionuclide issue and just to have lead copper rule problems. Yeah. We want to take another little 10-minute break. We took one break or two breaks? One? Okay, I think we need a second break, don't we? It's 5 after on my watch, about quarter after. Take a 10-minute break and we'll come back for a little stretch before we go to lunch. Capacity development. So, capacity development. And I had on that original game, the TMF. So what do those letters stand for again? Cheater. Last time I gave this class, I had Jason Kirkman in the class from the Southeast Regional Office, and I'm thinking, he knows every answer to every question I ask all day long. I'm going to say from now on, DNR is not allowed to come to a regulation class because they know all the answers, doggone it. All right, so technical, managerial, financial, right? Technical capacity means that we have trained and certified operators, that staff get away from time to time to go and continue their education, get renewal credit training to maintain those certificates that they work so hard to get. Well-maintained equipment. Rule requires or includes requirements for proper tools and safety equipment as well in Chapter 3 of the Drinking Water Regulations in Missouri. Water supply meets our demand, and we have a written emergency procedure, an EOP, Emergency Operations Plan. What's included? Now that's one of the chapters in the regulation. What's included in an emergency operations plan? What are some of the basic things you should just kind of iron out before an emergency ever occurs? What are some things you would think you would, even if you're not remembering offhand what's in your emergency operation plan?
Well, it has a contact list, who to contact for
Okay,
whatever you need.
good. A contact list. So DNR, maybe the local health department, the law enforcement, in case it would become something of concern about someone contaminating the water or breaking locks at your well house or whatever, entering a treatment plant. Chemical suppliers, maybe pump suppliers, chemical injection pumps as well as well pumps. Suppliers, list of those key folks, because you don't want to, in an emergency, have to root through and try to dig through files or something, try to find numbers so that you have those readily available. Also, it'd be nice to have just laid out who's authorized to spend money for repairs and when something breaks down. Sometimes you don't have the opportunity to go through the channels of hierarchy or authority at your system to get approvals through the normal process if you have an emergency breakdown of a well pump, for instance, and you're needing to act right away. There's also called the ERP, Emergency Response Plan. That's a little different. That was a little more detailed, trying to predict what is going to happen if we have an emergency. Down in this part of the country, this part of the state, talking about New Madrid, we could have a major earthquake here. We have had tornadoes affect some of our communities. We have had ice storms. We have had flooding. We've had all kinds of emergencies and disasters in the last 5 to 10 years. We've had a lot of them, actually. And it's meant to lay out, here's what we need to do to help protect ourselves as much as possible. Our components, our critical components, our pumps and things from disaster. And here's what we need to do to try to recover as quickly as possible. Having those key numbers in place, for contacts, emergency is one of those components too. What system, anybody know off the top of your head the population that you serve that triggers the requirement for you to have an emergency response plan?
It's 3,300 for everything else, and that might as well be for that too.
That is right, and you are right. That comes in for quite a few of the regulations, that 3,300. So if you serve more than 3,300 people, then you're required to have an emergency response plan. And then several years ago, when at this point it might be 8 years, 10 years ago, USDA Rural Development also implemented an emergency response plan for anybody who had funding through them, didn't they, Jim?
With the vulnerability assessment along with it.
Vulnerability assessment, yeah. I've forgotten about those things, but those were meant to actually determine where are our key points of vulnerability. Any item in your system, if it fails and causes you not to be able to produce water for your customers, is a single, I forget what they call it, a single item of catastrophe. One item that goes out that could cause you to not be able to produce water. So if we don't have a backup electrical source, like a generator, and we lose our power, unless we have a gravity feed system, some of our municipalities do have gravity feed that might have 2 days worth of water and might be able to buy us a little time. But if we don't have that, or a smaller system, we might be really critically impaired if we lose our power source. Remember what that law was way back? Remember in 9/11, the 9/11 event, 2001? The Twin Towers were attacked, destroyed. The Pentagon was attacked, and there was a plane that went down over Pennsylvania, and terrorists taken over the plane. What was the federal law that came about as a result of that? Remember? It's the law that required this emergency response plan for systems serving more than 3,300, and it was called Bioterrorism Act, the Bioterrorism Act, and that was a result of that tragic attack on our soil, terrorists. So technical capacity includes system maps, water sources, our treatment plant if we have one, pumping facilities, storage tanks, hydrants, valves, mains, and the sizes of those mains as well. And also in your records, you want to keep maintenance schedules, maintenance records for things that you have maintained through the years. Managerial capacity typically involves having a chain of command, who's in charge, who reports to whom up the chain, so we know that the operator out in the field maybe reports to a crew chief or somebody out there, or a distribution chief operator who maybe reports to someone else who has higher authority. It might be the public works director, might be the city administrator at a municipality. We know who's in charge, elected appointed officials' names with the chain of command, a chart that publicly displays and updates within 30 days of any changes. Those names, especially where local elected officials change from time to time. Operational regulatory reports are maintained. That's what the manager would do. A designated person should be on staff who communicates with DNR and who's DNR's contact point for your water system. A written rate structure. Where is that supposed to be kept, that rate structure? It's actually supposed to be publicly displayed, your water rates. Are public meetings required prior to changing water rates? At least one public meeting you're supposed to hold in advance of a rate structure change. And how long must the public meeting notice and meeting records be kept? And that's a 5-year period. 5 years. Means for addressing customer complaints. How long must those records be kept? Customer complaints are 5 years also. What are some of the types of customer complaints you get from time to time?
Low water pressure.
Okay, low water pressure would be one. What's something else that a customer might complain about?
My meter's bad.
Meter's bad? As in you're charging me too much?
Yeah.
Okay, yeah. Your meter's bad and we're charging you too little is the likely case. Anything else?
Taste.
Taste. Right, taste.
Color.
Odor. Sometimes discoloration. Sometimes we have red water coming out, or rusty looking water coming out of the tap, or brown or black water coming out of the tap or something. So those are things that might be complaints that the customer would issue. Financial capacity, we use generally accepted accounting principles. We take measures for collecting water payment, or we have measures in place, I should say, for collecting water payment, and records of collected versus not collected fees on a monthly basis, penalties for late and non-payments. What about folks in here? What kind of penalty do you have if customers don't pay their water bill? Now, I know you guys at the correction facility,
Turn the water.
maximum of life sentence.
We got a little bit of time.
They're already locked up.
We could turn the water off.
How about anybody else? You're not going to be able to match them, but how about anybody else?
Disconnect service,
Disconnect their service, okay. So how long do they get?
30 days.
30 days. So if they're 30 days overdue,
No, well, and this came from USDA, when we started the process for the funding. That's one of their big things, is nobody gets free water and bills have to be paid in 30 days. Because before that, our policy, and it was pretty lax, we had a 2-month policy. You could be up to 2 months behind before we'd actually do anything. And now it's 30 days.
okay.
If it's not paid in 30 days of the due date, we go and turn it off. And they raise the reconnection fee and raise the deposit fees on it.
Okay,
And
good.
that was a recommendation from USDA also.
Okay. Yeah, because sometimes those reconnect fees are so minimal that I'm told the same customers frequently don't pay, and they'd rather pay the extra.
They will try you to see if you'll actually they will actually pay the $50 just to see if you'll turn it off. I think sometimes.
Just to test
And
it.
there's a water district there by us, and from what I understand, their policy now is the first time, if they turn your water off, it's a $100 reconnect fee. And every time thereafter, it increases by $100 every time they come to reconnect.
Wow. So they've got an actual increasing level. That would certainly shock a person into,
But they also are in a class action lawsuit over their disconnection policy too.
Yeah, I've heard that too.
are they?
Yeah.
I don't know if it was over that, but I've heard there is a lawsuit.
Well, it's just part of it.
Okay.
However, the people that are in the lawsuit have only been disconnected once. It's only been $100. It's never, none of them have been elevated to the 200. But
Well, I've been told there's several out there that have been.
I don't know about that, but the ones that's filed the lawsuit, they tell me they have elevated to 200, but there again, there's some other policies that are in that lawsuit too.
So, well, as Liz Grove on our staff says, you gotta make it them feel it. You gotta have it hurt some. So what is, to an extent, too great of a penalty that might be decided over a lawsuit like that? I don't know if they'll set a precedent or not, but definitely you do want to make sure customers realize, I really need to start paying on a timely basis.
I did look in our rate study book that we do every other year. $100 is not uncommon for reconnection, for disconnection of payments. There's many systems that are charging $100 for that.
I think deposits or deposits for service have gone up considerably too, because we raised ours to 150. And I mean, I'm hearing from places that $300 and $400 is not all that uncommon for a security deposit to start service.
Those are good things to shore up your assurance that you're not going to be left holding the bag if somebody takes off owing for their water. Annual budget, revenues and expenses. We want to know how they compare to the budget for that year. So we budget so much money, we expect this much revenue, we expect this much in expenses. And as we go, especially we get halfway through the year, we want to know, well, how are we doing compared to how we mapped it out for the year? Maybe also how we did last year. Sometimes we get a report that shows, or produce a report that shows how we're doing compared to the year before, or maybe even 2 years before. 5-year capital improvement plan and the impacts from future regulations. How long must those records be kept? We typically would keep those budget records for 10 years. And then full cost recovery. What are some of the costs we incur for being in the business of delivering water to people? We've got a lot of costs, don't we? And we try to have rates, ideally, that would cover all those costs. So what are some of the things that cost?
Electrical,
Electric, that's a big one, isn't it?
State administrative fee
Okay, administrative fees,
and primacy fees.
primacy
Yeah.
fees, now that.
We
the
pay
cus-
that through the state.
Yeah, now that will be passed on directly to customers, the primacy fee fortunately, but it's still
No,
something
we
you have.
don't do it. We just, we have a set amount that they pay every
Oh,
year, and, because our system's so small.
I see,
But, but we have enough money, then we cover all that.
okay, okay. So those are good ones. What else do you use or need money for?
Labor.
Labor's a really big one, the biggest one probably. And what do you say back there?
Repair parts.
Repair parts.
Yeah.
Also heavy equipment, fuel, insurance for those vehicles and
Well,
workers, all that stuff.
Gotta pay the bill. Gotta pay the
What's
bill,
that?
man.
Loan payment?
Loan payment, yeah. Debt service reserves, typically about 10% of debt principal and interest. Our typical operating and maintenance expenses in a year, what we would normally spend in normal operations, replacement of parts and things. Maybe operating reserves of 1/10 of that O&M. would be good to have. Ideally, it'd be good to have an emergency fund, a repair, a replacement fund, capital improvement fund, even if those are not separate accounts, but at least separate ledger amounts for those that are designated for those purposes and not used for other things, and security even in there. Security would probably be with capital improvements. If we don't have fencing and locked gates, maybe lighting around critical infrastructure like well houses or treatment plants, maybe those would be things to consider, or around storage tanks, you know. So that's really what that's about, is making sure we remain solvent, the financial side of things, that we have proper management chain of command, and that we perform preventive maintenance on the technical side and have operators properly certified to do that. Any questions about that, or any other observations? I always call this the umbrella that covers everything, really. Technical, managerial, financial capacity. Part of that, of course, is being compliant with water regulations, all of that stuff.
For our small water facility, one of the best things we can do is just kind of keep it simple so people understand exactly what's being done and why.
And stay in compliance with the state, right? You are too.
Yeah. This, keep it simple for the customer so that they're not, here's the one I wanted to get to. I think I can go through this
DNR.
quickly before we do,
Keep DNR happy.
Yeah, stay in compliance. We
George
did
got a good suggestion, keep DNR happy.
keep DNR happy. That's right. And someone already mentioned having a good rapport with DNR, your local regional office. And it is good, because DNR is also a resource for you.
Yeah, we know we got
as
good
well.
water. Right?
Yep.
I
If
can
you
see
keep them happy, you're probably doing all the right
We know we got
things.
good water.
Other than our original kind of startup problems, DNR has been one of our best assets. They've been very helpful,
Yep.
Yeah.
very nice when you have a problem. You know, jumping on the other deputy just now, they know we're working on it.
That's good. I think that is the key.
Yeah.
They know you're working on it. If you're conscientious and you're trying to address an issue, even if you're not compliant, DNR knows you're working on it, you're being conscientious, you're asking questions, you're trying to get resources, so you are somebody they can see as really striving toward the goal of getting there. So they want to help you as much as they can along the way, provide resources for you. It's the systems that neglect their system, either the operational staff neglect the system, or the management allows the system to remain non-compliant for long periods of time and doesn't address issues that DNR has brought to their attention. Those are the systems that don't have necessarily the good rapport they should have with the regional office, and that's when DNR tends to want to put a little more heat on those systems. So,
Well, you can't blame them for being on your back when you have two bad water samples. The third one's due. And they call you and they say, this is going on, that's going on. You call your operator and he says, oh, I don't do that anymore.
yeah,
That happens.
that does happen, yeah. Well, keep them informed. One thing I wanted to do with this class, in addition to talk about the rules, or just talk about some of the resources that you have online with the Department of Natural Resources. So when you go to dnr.mo.gov, you get their home page, and if you click on forms and permits, there are a wealth of resources there at your fingertips on that. And I want to show, as we scroll down, so I click on that forms tab, under major water users, our major water use registration form, we used to do this. This is a voluntary measure to report as kind of like a census to DNR how much water is being used in a year's time at a community water system. It's again a voluntary thing, but it's something that DNR likes to kind of know so they can estimate future uses of water and our capacity as a state to provide water for our residents in Missouri. And then under water, heat pump and monitoring wells, we find additional things like the abandoned well form. The abandoned well form is not called abandoned well form, it's called public water supply notification form. But that's the form that you're expected to submit to DNR if any of the customers in your community have a private well, maybe they're hooking up to your public water supply. The status of that well, it's not to say they have to abandon it, even though that we use that term abandoned well. They might still use it for irrigation or for livestock, that water source. So they don't have to abandon the well. They might have already abandoned it and capped it. Or they might say, yeah, we are going to now connect to the water supply and abandon it, so they have another 90 days to cap it. The state simply wants to have a census of where these wells are in that. They say, I've heard in the past that they have 500,000 abandoned wells in Missouri. So each of those represents a potential conduit down to aquifers that could potentially contaminate water, groundwater sources in Missouri. So they want to get as much a handle on those abandoned wells as they can to know where they are and what their status is, if they've been capped or
When
not.
a public water, when a public water supply extends their lines and takes in these people that are on wells,
Mm-hmm.
what percent of the abandoned well forms do you get? Does the DNR get?
They should, well, I can't say. I don't know. And I don't track that, but they should get one for each of those wells.
They should,
They should. You're right. They should.
but they don't push that at all.
They've pushed it more of late than they used to. Yeah, in the past, you hardly ever heard of it. Now, we've been reminded of it recently that DNR really wants system operators to know they're obligated by state regulation to submit those forms. So,
Ah,
Yeah, but if
I
they
beg
don't
to
know about
differ
the
with you on
well,
that.
if they don't know about the well, how are they gonna say you didn't go by procedure?
Yeah,
yeah.
but I know a lot of wells that are not in use, they just, when they go by the well, to put the public water supply line there, and they just cut it off, and go on.
Yeah, and don't properly cap it. And see, I think DNR also has funding to help provide for the cost of that, I believe. So,
Isn't there a place on that form where if they keep the well for like irrigation or something, they mark that they're keeping it? They just have to have the area.
yep, they are certainly allowed to keep the well in use, so.
Sure.
So some of those are probably still in use, and
Yeah.
that's fine. DNR just wants to know what their status is, and yes, that's where a lot of times the problem happens. We don't get that communication.
Yeah.
Communication's some big problem for almost any arena of life, isn't it? Communication. So that they're urging operators to do.
Hey, so like when the county comes here, when people that have wells and stuff, and the county, do they have to note that they had a well and they're not using it
I
now?
don't think so.
Because, they had that, when the county come in there and put that water down, and then up by Roberts,
Yeah.
and stuff, so, do they have to notify the state, or
I don't think
If it's a
there's
private well,
notification required, is it?
If a water district moves into an area that
then
was,
everybody has wells,
everybody has wells and they're starting to hook people up,
yeah,
then they should be doing a systematic documentation of all of those wells.
that those people, unless they document it that they're gonna keep them and use them for irrigation or something like that.
Right.
But
Even
they
if-
should.
Even if they're keeping them, that still is documented that they're keeping them
Oh,
active.
okay.
So they should be doing it.
I know of a well that's had a berm built over it. And it's a flowing well.
Oh, is that right?
What's that?
One of the artesian wells down
Well,
there?
it flows from time to time, you know, it overflows.
Oh, yeah?
Because I was supposed to take the equipment out, and I went back to take the equipment out, and they had a berm built over it.
Oh. To try to prevent it from flooding
Well, it just
an area. Is
for the property on the south side of it,
that right?
yeah.
Yeah, so that's a potential
And that's-
contamination
That's
source.
out at the Egypt Mills area.
Yeah, yeah. I suspect there are probably quite a few that are
Yeah,
not capped and are just simply abandoned potential sources. We get questions occasionally about contract operator forms, and yes, there is a contract operator form that you actually fill out that has the basic information about who is the person and the name and where that person is, and I don't know all the details they list on it. It's a 1 or 2 page document, I believe, that you fill out. And DNR likes to see that you've got this contract between that person, so everybody kind of knows what is expected of that chief operator.
Yeah.
Some systems, like the city of Fredericktown, city of Poplar Bluff, city of Louisiana, up north of St. Louis, have recently started implementing UV radiation of their water for cryptosporidium, those surface water systems. And I know I did have one person specifically say, what are we supposed to do now that we've got this thing in place? Well, there is a monthly reporting form that you actually have to fill out, and that is right there under public drinking water. There's also a notification of fluoride modification form. If you want to order bacteriological water analysis sample bottles, that happens simply when a different operator is now in charge of a system and the state still has the name of the previous operator, and you want to simply maybe make changes, or you know you need some bottles, you're running low. So those are easy things to access right there on the state form. Construction permit, talked about that originally under construction there. So those are some handy resources from Department of Natural Resources. I have 10 minutes till 12, and I'm inclined to say, shall we take lunch till 1 o'clock?